Hi, I'm Desiree Romero, and today we will be talking about stoichiometry. Stoichiometry is the scientist's way of measuring elements. There are 3 different types of conversion factors for stoichiometry. The first one is molar mass. You use molar mass when you're going from grams to moles or moles to grams. The second one is mole to mole ratio. You use mole to mole ratio whenever you are changing your compound. This mole to mole ratio is found in your balanced equation. The third and final type of conversion factor for stoichiometry is Avogadro's number. Avogadro's number is 6.022 times 10 to the 23rd. This equals 1 mole and is used when the key words atoms, molecules, or particles are given in your question that you are trying to answer. Here are a few practice problems. How many moles of KCl will be formed from 2.73 moles of KClO3? Well, the first thing you have to do is use the number that is given. The number that is given is 2.73 moles of KClO3. Then you multiply it by how many moles of KCl and KClO3 there are. So there is 2 mole KClO3 and there is 2 mole KCl. You get these numbers, the 2 and the 2, from your balanced equation. And you put KClO3 on the bottom here because you put it here. Then you cross off the KClO3s on this one, and you are left with moles of KCl. The reason you use the numbers in the balanced equations is because you are using a mole to mole ratio. And remember, when you are using a mole to mole ratio, it is because you are changing your compound. See, we started with KClO3, and the question is asking for KCl. So, you multiply 2.73 by 2 and divide by 2 to get 2.73 moles of KCl. And that is your final answer. The last question says, how many molecules of carbon dioxide are required to react with 174 grams of carbon monoxide? The question says molecules, so molecules is a key word, meaning that we are going to have to use Avogadro's number at some point in this problem. Since we are going from grams to molecules, first we must go from grams to moles, then use the mole to mole ratio, and then use Avogadro's number. Therefore, we start with the number we are given, which is 174 grams of carbon monoxide, and we multiply that by the molar mass, which is 28.01 grams of carbon monoxide, equals 1 mole. These are equivalent to each other. Then we use the mole to mole ratio, which is 2 moles of CO and equals 2 moles of CO2. After using the mole to mole ratio to get your new compound, which is CO2, you then multiply that by 1 mole of CO2 with Avogadro's number on top of that, which is 6.22 times 10 to the 23rd molecule of CO2. And now we are in molecules. After multiplying this by this by this by this and dividing it by this, you get 3.74 times 10 to the 24 molecules of CO2.